Hello, buddy. How are you?
I'm just a computer program, but thank you for asking. How can I assist you today? You're welcome. If you have any more questions or need assistance, feel free to ask.
So, in this video, you'll learn how to build such kind of bi-directional voice-enabled chatbot with n8n. And all the resources and workflows that I've used in this video are available for you to download for free. So, make sure to download and use it. Make sure to watch this video till the end. And please excuse me, the audio in the initial part of this video is a bit unstable. So, I recommend you to watch it in a low volume. And going forward, it should be fine. So, let's begin. So these are the topics that we'll be touching upon today. So we've just seen the demo. So next we'll actually take a look at the workflow, right? The backend of how we handle this audio to audio conversation. Right? There are two different approaches that I'm trying to follow. So the approach one is a naive approach, and then the second one is a bit more optimized that you can use in production use case. And then after that, we're going to compare both of those approaches and see which one is best for what use case. And then we'll see how you can set it up yourself, as I'll be providing the template for you to download. And then finally we'll take a look at the possible use cases of this kind of solution, right, where we use audio enabled chatbots to serve different purposes, right? So these are the topics that I'll be covering today in this video. So let's begin. So starting from the approach one, right, the workflow walkthrough of approach one, right? This one. So what's this approach? So how we do this is we send the raw base64 audio in the response, right? So this is how it happens. So send and receive audio messages directly as base64 encoded data in each chatbot response, right? So this is the gist of it, and let me explain how everything works, and I'll show you how it looks like in the n8n dashboard, right? So how it works. So the chat widget that we're using records the audio user's voice as input and sends it to n8n. And then the backend processes the voice input using a speech to text model, right, to transcribe the user's audio into text. So we convert user's audio into text first, and then we use a TTS model, a text to speech service, to generate a reply as audio, right? And then the audio file is converted to a base64 string that will be then just passing right back as the response. So the backend responds to the chat widget carrying the base64 encoded data, right, along with the mime type. And then the chat widget instantly renders and plays the audio as soon as the response arrives. So this is how it works, right? So first we send the audio to our backend, and then we extract text from it, and then we process the text by passing it to some kind of AI model or however our workflow is designed to be. And then once we generate the response, we then take that text response and send it back to a text to speech model so that we can generate the final audio. Then once we receive the audio, we're gonna take the base64 data, right? We're gonna convert that into a base64 encoded string. And then we're gonna pass that to our widget, and our widget plays the audio, right? So now let me just take you to the n8n workflow that's serving as the backend, right, and show you how everything works. So this is how it looks like, and let me actually click on the executions and take you through step by step. So this was the latest execution, and let me just wait for it to load. Yep. So this is how it looks like. So this part that you're seeing here, the first part, so this entire workflow is split into two different parts. So this part right here is responsible for taking the audio as input and converting that into text, right? So essentially what we're doing is speech to text over here. So once we do speech to text, we're just passing the text to our AI agent so that we can generate a response, right? Or in this case, it's a simple workflow that has a single AI agent that takes in user input and returns back an output. But in your case, it might be different. So I'm not going to stress too much about this particular part because I've already covered this in another video. I'll probably link that somewhere on top. So I'll just run you through very quickly about this. So what we do is we receive the audio from here, right, in the webhook node, and then we extract any, if there's any binary file in this. So this was actually the text conversation. Let me show you the binary one. So this workflow is designed in such a way that handles both audio and also the text input, right? So I've showed you in the demo, the first part was the audio and then second part was the text. So using webhook node, we accept the audio file, right, from users, and then over here in this code node, we extract the raw data from the binary so that we can process it further in our workflow. Right? There's no way for us to pass around this binary data throughout this workflow. That's why we had to do this. And then after that, we have this split out node, which takes the data that was extracted and then passes it through this loop over node. And then we have the switch node here, which decides where to send the data to, right, depending on the type. So if it's an audio file, it passes it to this part. If it's a text file, then it directly passes it to our agent, right? So this part that you're seeing on top, this is actually a workaround for this workflow to work on a cloud version of n8n, because this otherwise this wouldn't work. For some reason, when dealing with binary files, cloud version of n8n, it stores the data in a different format that's not really useful for us. So that's why I had to add a workaround around this part. So what we do is, we just carry over the same binary file as usual over here on top, and then we have this merge block, right? This merge block gets triggered only the switch block takes this path, right? Otherwise it won't get triggered. So our goal from this section on top is to make sure that if there's any audio file in the request, we generate the text out of it. So that's this part. Otherwise it'll just go to the agent directly, right? So that's what this logic is about. So this top part is responsible for just carrying over the binary file which was sent in the request, and then based on the the type of request, which in our case is audio here, it'll just trigger this merge block and then pass it through our speech to text model, right? So I'm using ElevenLabs here. So this is the endpoint, as you can see, ElevenLabs speech to text, and then I'm just passing all the data that's necessary, right? Like the API key and the model name, and also the binary file, right, that I received over here is the upload. And then the language code, right, I'm just hard coding it to use English. And once we generate the text, right, so this is what we get. Our agent receives the text from here. It says, hello buddy, how are you? So this is what I said in the demo. This part will be handled by the agent. This will be an LLM call again, and then this is the response, right? This is a text response from our LLM model. And then we use the text to speech model. Again, I'm using ElevenLabs. So I'm using text to speech APIs to generate audio from text. Again, I'm passing all the necessary details from here. So I'm just passing the JSON output that I received from the agent, right, as input. And then once I get back the audio response, I'm again passing it through the code block so that we can extract the data, right, like the text data that we need. In our case, like I said, we are sending the base 64 data of the audio file, right? So that's what we need. So I'm just passing it through this little code that just extracts the data that we need, right? So it extracts all kind of data like MIME type, file extension, data, and file size. And we are really worried about just these two parts, which is data and MIME type. And then we're going to take that and pass it in the response, right? So this is the structure that our widget expects, right, for it to work properly and render everything seamlessly, right? So output is a string, so you can just pass the raw text, and it'll just show the text as usual as the response. And then inside this attachments array, so this is where we are passing the MIME type and also the raw data, right? So as you can see, so it's an object here, and this carries this data, right? So type is data URL, and then the data is the actual data, which is our base 64 version. And then we have MIME type is basically the type of file, right? So this is an audio in this case. And then we have another option called as autoplay audio. So this is a boolean value. You can either set it to true or false depending on how you want it to be. And if you set it to true, it's going to be played automatically as soon as it receives the audio. Otherwise, users would have to click manually on that play button to play the audio. So this is how it looks like. So our widget is actually built using n8n chat UI, So you can take a look at this and build your free widget for your n8n in minutes. So if you just go to the doc section, I'll cover more about this part in further sections. So if you just go to the documentation, and at the end there's a section called as media attachment. So this is the place where you can find the documentation on how the response should be if you're trying to send an audio file in the response, right? So this is what we're following, and as you can see, this is the same structure that our response follows here. So that's about it. So this is how it looks like. So the first part, like I said, is about speech to text, and then here we do text to speech and return the response in a way that the widget expects, and then everything gets rendered and users can listen to the audio which was generated. So this was our first approach, right? And like I said, this works with both cases. So you can either send audio as input and also text as input, right? So in our second case, we sent the text as input, and it worked without any issues, right? So as you can see, we received nice thanks as input, as text input, right? And then we go through this path again. Remember, this switch block is responsible for taking the right direction depending on the type of input, right? In this case, this since this is not audio file, it did not take this path, so it just took directly the fallback path, and then directly passed the input, right, to our agent, and then our agent took it forward from here, and then we generated the audio and then sent it back in the response. So it works with both cases, right? So that's how this is built, and this was the first approach, right, of sending a raw base 64 data of your audio file, right? So we've seen how it looks like in the backend, and what is this good for? So this approach is actually good for simple proof concept demos, right, and then rapid prototyping. And if you want to build something really quick around audio to audio conversations inside your chatbot, then this approach works well. And also situations where audio file size will always be very small, like short examples, short replies, or single turn conversations and things like this. So if you're trying to build like complete audio to audio all in all a solution, right, then this approach doesn't really work that well, as there are a lot of issues around this type of this approach. I'll talk about the downsides of this approach in the further sections, but yeah, so this is what it's good for. And also another thing is, like I said, over here, if I just go back to the widget part, even if I just refresh this page again, you can see all the previous chat messages gets loaded, right? So this happens because we are storing all the data inside our local storage, like the browser local storage. So there's also a limitation around this, right? So like I said, base 64 data is really huge, and the browser local storage also has a limit, right? It has a certain storage limit that it can hold, and after that it'll just fail to accommodate more data. So that's why we need to be really careful around this, because once we hit the storage limit, then the audio files will not be stored on the browser. And then if user tries to refresh and tries to listen to the audio, right, they won't be able to do it because we would have hit the storage limit and we wouldn't have the data to play the audio. So that's why this is also another edge case, right, that we want to be aware of. This particular approach is suitable for sending really small audio file size or sending audio files every now and then between the conversation. This was about the first approach, and then let's go to the second approach. So this is the optimized one. So here what we do is we upload audio response that we generated to cloud storage first, and then we provide a lightweight audio link for seamless voice conversations. So this is how this approach works, and this is much more optimized compared to the first method. So let me explain how this works, and I'll show you the workflow. So how it works: again, the chat widget records the user's voice input and sends it to n8n. Then again, we do the speech to text. We generate the text. After generating the text, what we do is we pass it through a TTS model again. So this generates the audio that we need. So as the audio file is generated, what we do in the second approach is we first upload that to a cloud storage, right? You can choose any provider. In my case, I'm using Cloudflare R2. So once we generate the audio file, what we do is we upload it to a cloud storage. So in my case, I'm using Cloudflare R2. So this seems to be working fine, and it also gives me a generous free tier. And you can just use any other cloud provider. In your case, you might use Amazon S3 or DigitalOcean Spaces. There are so many. And once we upload the audio file, what we do is we actually generate a public URL through which we can access the file which we just uploaded, right? So we're going to generate that public download link, and then we'll just pass that link back to our chat widget in the response. So this is how it works. So this way we can actually keep the response really small, and we don't really have to deal with that really large base64 data. This is an optimized version compared to what we've seen before. And once we generate and return back the response, it's also important for us to periodically clear or delete those audio files again, right? So assume your users will have conversations for about 5-10 minutes, and then they'll just leave the site or the widget, right? And then our audio file is still lying around in our cloud storage, so we just don't want that anymore. It's also important to automatically clean up those unused files that we don't need anymore. So we can also set up those auto cleanup workflows. I actually have a very simple one right now, but I didn't find much time to implement this workflow. But I've given you like a starter node that you can just build on top of. So this is also an important point to consider, right? In our case, if you're trying to use the second approach of using a cloud provider uh, to store our audio files. And so this was about it, and let me show you how it looks like. If I just go back, I have it in a separate workflow. It's this one. This workflow is again split into two different parts, two different workflows, I would say. The first one has two sections as usual. The first part covers converting speech to text, and then this is where we use the text further and generate the audio. And then the second point which I told you about is about the periodic cleanup, right? So I didn't actually completely implement this flow, but I have this single node which actually deletes all the audio files, which I'll touch upon in a bit. But yeah, this is how it looks like overall. So first part, again, I'm not going to touch this again. It's the same. So once we generate the text input, we pass it through our AI agent, and then again we use the same ElevenLabs TTS model. So until here, I believe everything is same, regardless of which approach you're trying to use. Approach 1 and 2, it's the same till here. Once we generate the audio from our text to speech model, so this is where this part is different. So let me actually show you how this works, right? Before I This will give you a better idea. So let me copy this webhook URL, and I'm using this online HTML environment here, Replet's environment. Let me just change the webhook URL to use this new workflow. Stop and then rerun. And let me just refresh this. I don't think you will be able to hear the voice because of the current setup. So let me just run this again. Hello, buddy. How are you? So you can see it. Just pause this. As you can, I don't think you can hear that, but yeah. So you got the response, and we also got the audio response that we needed, and it started playing automatically. So this was the second approach, and now let me go to the executions and take you through this step by step. Right, you can see everything worked fine. So let me just start from here. So this is the input that we got. Hello, buddy. How are you? And then this is the response, right? And again, we sent over the same text input to our text to speech model, and we got back this audio back as a response. And then once we got the audio as response, what we are trying to do over here is we are using this edit field node. So this is just to initiate some variables that we'll be using in the coming nodes. So here I'm just setting the file name, right? So file name of this audio file, right? Before actually uploading this to our cloud storage, so we need to set a name for this file so that we can access it later. So I'm just creating a new folder here. So based on the session ID, right? So our widget also sends session ID along with each chat message, right? All the audio conversation that happens within that session will be stored inside a single folder. So that's basically what we're trying to do here. So this is the session ID, and then the file name is very simple, audio, and then date dot now. This generates a random timestamp that we can use, and then we have file mime type, which I'm just again extracting it from the data that we already have, right? So once we initiate these variables, it's time now for us to upload this audio file to our cloud storage, right? So this is the node that I'm using. This is the S3 node, I think. So this is a built-in node in n8n. So this node can be used to upload files to any cloud provider which is S3 compatible. So you can upload it to Cloudflare R2 or Amazon S3 or DigitalOcean Spaces or any other provider which supports S3 compatible APIs. So R2 supports it. So I'm just trying to use it directly from here. This is how it looks like. Right. Let me actually show you how to actually set this up. This is really simple. So if I just go back over here and click on this part, so this is the first section that you need to set up, which is the credential. Just click on this. So these are the data, like the important keys that we need to set up to successfully establish connection. Right? Let me show you how you can do that. So if you're trying to use Cloudflare R2, so this is the same approach that you need to follow. So just log in into your Cloudflare dashboard, and on the left hand sidebar, you can see an option here which says R2 object storage. Just click on that, and you can see this section. So by default, you would see actually a page where you need to fill in your credit card details if you're doing it for the first time, right? But no need to worry; they won't charge you until you hit a certain limit. But the free limit is very generous. I think that's more than enough. That's what I'm currently using. Once you fill in your credit card details, you can see this section, and this is where you can start creating your buckets, right? So first, I have created my own bucket here, and I've created this audio bucket here. If I just click on this, so you can see this already stores a single folder. So this is the file that you can, if you just click on this, you can actually see the same audio file which was sent back in our in our demo right here, this one. So this audio file is, it's actually the same, this one I'll show you. So you can see that the workflow successfully executed, and we are able to store the audio files inside our cloud storage and able to access it from here. Let me just get back to the main point on setting up this connection, right? So once you create your bucket, what you do is just go back over here, and on top here you can see this drop down. It says use R2 with APIs and manage API tokens. So just click on this manage API tokens, and you just need to create an account API token here. So if you just click on account um, API token, and then just give this access object read and write, and then you can give your token name whatever you like, and then specify bucket and tie it to my specific audio bucket, and then TTL is basically how long you want this key to stay active. In my case, I'm just setting it to forever. I'll just remove it anyways. Once you click on this create account API token, so this is what you'll get, right? After filling all that information, so this is what you'll get, and these are the three details that we are really interested in. If we just go back to my dashboard, and as you can see, these are the details that I just need to fill in. So starting from this S3 endpoint, so this is the one that you just need to copy, right? Click to copy. You just need to copy paste this as your S3 endpoint. And coming to region, you can actually find your region inside the settings of this, which I'll show you in a bit. But if I just go back to access key ID, let me just fill in these details. You can actually add region at the end, but first you can just add the endpoint, and then key access key ID is something you can get it from here. It's this one, and then you have secret access key. Again, it's this one, secret access key. Once you paste these three values, right, that's all we need here. And then if you just go back for to get the region key, all you need to do is just go back to your bucket and click on settings, right? So this is where you get your location, right? Your region. So in my case it is APAC, Asia Pacific. So I'm just entering the same over here, APAC. So in your case it will be different, so just try adding your right region. I think that you'll get it from here. Just try to add that, and it should work fine. So once you fill in all these four details, just click on save, and you've successfully set up the connection with your cloud provider. And then you just need to define the type of operation that you're trying to do here. So in my case, I'm performing an operation on a file, not on bucket, not on folder. And the operation is upload. Remember, we're trying to upload an audio file here, and then add the bucket name. In my case, it's this audio bucket. And then I'm trying to pass a binary file, right? The binary file which I receive from my text to speech model. And once I do that, let me just go back to this executions part. Yep, if I just expand this, so this is what it looks like. So everything looks fine, and the this is where I'm just selecting the file name. Remember, I'm getting this from one of my previous notes over here, right? I'm just setting it and picking it from here. Sorry, the file name, binary file, and then input binary field. This is the data, right? This is the audio file that I'm trying to upload, and once I do that, I get this success true as response. And now it's time to generate the public URL, right, through which I can access the uploaded audio file. So you just need to get this base URL. You can get it again from your bucket, going to settings, and over here you'll get this public development URL, right? So by default you would see something like this, and you just need to click on enable, and once you click on enable, you'll see this section, right? It'll just unlock this, and it'll give you this base URL. So this is what we need, and this is the base URL. I just copy paste it here, and then you just need to append the file name at the end to access the file directly. So this is how it works. So the base URL, you can get it from a dashboard, and then the file name, right? So this is the reason why I'm storing the file name in a specific node, so that I can access it further in my other nodes. So at the end, I'm just adding the file name so that I can directly get the audio URL. So this is the URL. So if I just open this in a new tab, it's playing the audio file here. So this is the direct link for that audio. And once I get the audio URL, I'm just passing it back to my chat widget in this specific format. So type is URL, not data URL, unlike in my first approach. And then I'm just passing the audio URL and along with all the other options, right? So this is how it looks like. And let me just go back. Perfect. So this was about the second approach, and let me tell you what this approach is good for. So this is great for building scalable and production ready chatbots, because this is the optimized version compared to our first approach, right, where we are storing everything inside our cloud storage, and we don't really have any restrictions around how big the file can be, right? Because we are just storing everything inside a cloud and just returning back the URL of it. And then handling large or long running audio conversations, this is good for this purpose, right? You can send really large files in the response, and also if you're trying to build like a full on audio to audio conversation chatbot, then this is good for this purpose as well. And efficiently managing storage and ensuring a seamless user experience, right? So this is one of the major advantages. Like I said, in the first approach, we are sending the base 64 data, right, in the response, and that just takes a lot of space, both in the response and also in your browser local storage, right? This approach is much better compared to that, as the response is lighter, and also it takes very less space in your local storage. So this was about the second approach. And now let's actually compare both of these approaches very quick, and allow you to choose the one which works best for you. Right. So on the left, we have our initial approach, our naive approach, which is sending raw base 64 audio in the response. And then on the right, we have the optimized version, which is sending the audio URL, right, in the response. So starting from this one, the naive approach. The pros are simplicity, right? It's easy to set up, no need for any external storage, and no external dependency, right? You don't need to manage any connection with other providers, and a quick, great for quick demos. If you're, it's really good for building very quick prototypes. And cons, like I said, payload bloat. Base 64 encoding inflates the file size, so even short audio clips can quickly make the response very large. And local storage limits, again, browser have strict local storage quotas, and large responses can easily exceed those limits. And performance issues, heavy payloads may lead to slow loads and high memory use on the client side, right? So if the response is really huge, then it can take a lot longer compared to a shorter response. And then limited scalability, right? Not suitable for production or long running conversations with many audio files. So these are the cons with this naive approach. Then talking about the optimized approach, right? The pros are efficient payloads, right? Only a small JSON response is sent, where we just send the direct audio URL in the response, and we don't need to worry about exceeding local storage limits, right, with this approach. And then it's scalable, can handle long conversations and large audio files without any performance drops. And cleanup workflow, automated deletion of old or unused audio files ensure you won't waste cloud storage or incur unnecessary costs. So actually I forgot to tell you about this. Let me just go back, right? So you've seen this, like I said, in the second approach, we have two different workflows. The first one is responsible for handling the conversation, and then the second one is actually a workflow that clears or deletes the audio file which was stored in our cloud storage. Right? Remember, we have this audio file that we already have, and we need to make sure to periodically remove these files. Right? Otherwise, we just end up storing those, and we would have to pay for it, right? So this again I'm using the, let me just explain this very quickly. Again, I'm using the same S3 node, and this time I'm performing this delete operation, and bucket name is audio and folder key, right? So I'm performing on folder, not on file. So because of that, it's asking me for the folder key. So the folder key is basically the session ID, right? So in my case, what I'm doing is I'm just hard coding the values right here, to delete them, right? If I just go back to executions, and let me just wait for it. Yeah, if I just open this one, so this is the folder key, right? So this is the session ID that we have. Let me just copy, go back, add this session key, and click on test step. So it should basically delete that folder now. So it says deleted key. If I just take a look, I refresh this again, so as you can see, it deleted the entry. So this was actually a manual approach. I'm not anyway recommending you to do this, because this is actually an incomplete one. I didn't find much time to completely build this out, but yeah. So you have this delete node that basically deletes your folders, right, based on sessions. So what you can do over here is, once you upload the files, you can probably keep track of all the session IDs in some kind of database like Airtable or Google Sheets, right after this node. And then you can set up a cron job over here, like which runs like every 6 hours or 12 hours, depending on how often you want it. Whenever it runs, it basically fetches all the session IDs, I mean the folder keys, from your same database, and then it just deletes all of them one by one. So this is how it should be like. But in my case, I'm just doing it manually, and you can take this template forward and just complete that. It should be very simple, right? Let me just save this. So this was about it. If I just go back to the section, yep, we have seen the cleanup workflow. This needs to be automated, right? And production ready, right? Best practice for real deployments, especially with high user traffic. So this, the second approach is production ready, and it's also scalable. And the cons is again slight setup overhead, which is you need to connect to your cloud storage, set up and manage your API credentials. So connecting with your cloud provider is another overhead, and slightly more complex logic compared to our first approach. It adds workflow steps to name files, upload, generate URLs, and handle cleanup logic as well. So this is slightly complex. So when compared to first approach, this approach takes a little longer to give us the response, right? As it has multiple steps involved in between, right? So this is another a limitation with this approach, right? And then in a nutshell, this is what it looks like. So the base 64, or the first approach, right, where we send out the raw data or audio data, is great for rapid prototyping and quick tests, but hits major limitations with real use case, right? And if you're trying to use this approach, the first approach, then you need to make sure to keep these pros and cons in mind. So coming to the second approach, the cloud storage approach is ideal for any real world deployment with best practices for storage management and also scalability. And again, every approach has its own pros and cons. You just need to do that trade off and choose the one which works best for you, right? So this was about comparison, right? And yep, next going forward, which is how can you set it up yourself, right? So again, both the templates will be available for you to download, and you can set them and then adjust and adapt with your existing workflows, right? Remember, I'm just using a simple agent here, but you just replace this with your core logic. And coming to the front end, right, which is the widget part. So there are two different ways. One is you can use n8n chat UI to just build your widget within a couple of minutes, right? So it basically has all the features and functionalities that's required, right? You don't need to set up anything more, so you can just directly build the widget and connect it to your backend. So let me just show you that very quick. So if I just go back to my n8n chat UI and create an account, and this is the chatbot that I've built and I've used in the demo as well. So voice chatbot, so you can just create your chatbot and customize it however you like, and you can make changes right from here and see the changes live as they happen, right? So like for example, avatar size you can change, and customize each and every part of it. And if you just scroll down to the bottom here, you have this voice input settings. So this is where you can enable this voice input, right? If I just turn it off, you won't see the mic icon. If I just turn it on, you can see this, right? So similarly, you can just customize every single part of it. Not just that, you have advanced options like file uploads, and you can do a lot more from here. And once you're happy with your widget, right, and just need to click on save and just copy this embed code, right? Just copy this and paste it into your website like this, and make sure to replace your n8n chat URL with your backend URL, right? And that's it, right? And just run it again, and you can see your widget. So this is a very simple and straightforward approach of using n8n chat UI to build your front end. So if you had to use n8n chat UI for this to build this voice to voice audio chatbot, then these are the steps that you need to follow. First is creating your widget. Just head over to n8n chat UI, create your widget, personalize it however you like. And then second is configure your backend, right? Use this template, make changes however you like. And once you're ready, just connect your webhook to the widget, right? Like I showed you here, over here. And I've also made a dedicated video on how to use n8n chat UI, and you can check that video on top again to learn more about this, right? And then if you want to, however, if you want to have your own front end, you can do that as well. It's not restricted to only work with n8n chat UI. Right? You can just download the template as usual and build the front end to make sure to accept both audio files and text, and then receive the audio data back as a response and display it inside your front end, right? So you can do. Next is common use cases for this kind of audio enabled chatbots. There are a lot of use cases. I've just noted some over here. Accessibility, so help visually impaired users or anyone who prefers listening over reading, right? And this also gives you like a bot, like a hands-free bot experience. Language learning, right? Enable students to practice speaking and listening with instant voice feedback and pronunciation help. Virtual assistants and customer support make live chat personal and natural by letting users talk instead of typing. Healthcare and wellness, again, interactive storytelling and games, so you can build these kind of applications as well with this. Language translation, again, this is another major benefit, which is to build bots that translate spoken phrases in real time and read them aloud in target language, right? So the bottom line is any scenario, it works with any scenario where talking and listening is faster, more natural, and more inclusive than typing and reading, right? So these were some of the most common use cases. and you can just fine tune it to your own purpose as well. Perfect then. Thank you so much for watching this video, and I think this was a very lengthy video. If you have any more questions, feel free to let me know, and check out n8n chat UI and launch your widget in minutes for free and connect it to your backend to get your a bi-directional voice chatbot up and running. And if you want to work with me to build practical workflows, automations, or AI solutions, or if you're unsure on how AI can benefit you and your business, you can just book a consultation call with me. So where we can just have a friendly conversation. And this is the link to book a meeting. I'll paste this again in the description section as well, and you can check it out from there as well. And like I said, download all the resources that I've used in this video. Like both the workflows will be available for you to download. The URL upload and also the raw data upload, like both approaches. And also let me know what you would like to see next. Thank you so much for your patience, and I'll see you again in another video. Until then, take care. Good day.